In this lesson, we're going to solve multi-step linear equations in one variable. So they're multi-step because we're going to do more than two steps. We're going to probably have to distribute or combine some like terms before we're able to isolate the variable. Just a quick review, if you did not watch the previous video that was solving linear equations that were in two steps, a linear equation in one variable is just ax plus b, where a and b are coefficients or constants, and x is the variable. We could have three possible solutions. One is that there is no solution, which we saw a lot of in the previous video, that x is equal to a number. Or we could have no solution. We'll see that in this video where we find that the left-hand side does not equal the right-hand side, so we're given a false statement. The last possible solution we could have is infinitely many solutions, so that's when we have a true statement, so something like 3 equals 3. So no matter what x is, it doesn't matter. We're always going to have a true statement. That means x can be any value, and we're always going to have a solution for our equation. The steps to solve a linear equation, again, were to clear any fractions by multiplying through by the least common denominator, use the distributive property, combine any like terms, isolate our variable, and then check the solution by substituting into the original problem. So here we have 4x plus 6 plus 3 is equal to 17. So this is a multi-step equation because before we can isolate the x, we should really combine that 6 and 3. So 4x plus 9 is equal to 17. Now we have a two-step equation. Subtract the 9. 4x is equal to 8. And x is equal to 2. Again, when we check our solution, always go back to the original problem because you never know where in the problem you could have made a mistake. So we need to make sure that our solution satisfies the problem that we were asked. This will be very important when we start looking at other types of equations where our x values are actually limited because of the type of equation it is. So there are some equations, if you think of, say, a square root, where we can only have positives under the radical sign. That's where it's important to make sure that we check our answer in the original problem. But we're getting ahead of ourselves, so we'll talk about that in those videos to come. 14x plus 5 minus 14x is equal to negative 10. So again, I'm going to combine my like terms. 14x minus 14x, well, they just cancel each other out. So I'm left with 5 is equal to negative 10. I know that is never a true statement, so they're not equal to each other. In this case, we have no solution. Because there is no x value that's going to satisfy the original equation. In this example, we see we need to use the distributive property first. So I have negative 30x minus 30 is equal to 30. I'm going to add 30 to both sides. Negative 30x is equal to 60. Divide each side by negative 30. X is equal to a negative 2. In this example, we have 12 is equal to 4 times x plus 3 minus x. So again, I want to simplify this expression here on the right-hand side. So I'm going to start by looking at the parentheses. I have x plus 3 minus x, and we notice that the x's are going to cancel. So I'm left with 12 is equal to 4 times 3. 12 is equal to 12. So in this case, since I have one number equal to itself, I have infinitely many solutions. That means it doesn't matter what value you put in for x, we're always going to have a true statement here, which is going to be a solution. let's choose x is equal to 1, since 1 is a very easy number to work with. 12 is equal to 4 times 1 plus 3 minus 1. I would start with the parentheses. 1 plus 3 is 4. 4 minus 1 is 3. So no matter what, I'm going to get 4 times 3 on the right-hand side, which gives me 12 equals 12. In this example, we have negative 3 plus 5 times x plus 6 is equal to 37. We need to simplify the expression on the left-hand side here before I can isolate the x. So when we simplify expressions, we always go back to our order of operations. So my parentheses, I see that there's nothing in there that can be simplified the way it is. There's no exponents, so I move on to multiplication and division. Here I can multiply this entire set of parentheses by 5 by using the distributive property. So negative 3 plus 5x plus 30 is equal to 37. Now that I've used the distributive property and I've gotten rid of all the parentheses, I can combine my like terms. 5x plus 27 is equal to 37. Subtract 27 from both sides. 5x is equal to 10. Divide by the 5. X is equal to 2. You want to get in the habit of always writing out all your steps. A couple reasons why. 1, you want to make sure that you don't mess up any of your signs. 2, if you're doing this for a class, you want to make sure that you can get any partial credit if you do happen to make a small mistake somewhere. The only way that you can get partial credit is by showing all of your work. And honestly, you will get better at it by showing the same steps over and over again. It helps you remember the process. One thing that you may want to note is that we did not combine the negative 3 and the 5 first, because remember, we always do multiplication before we would do addition or subtraction. So let's check this one since we haven't checked a problem yet in this lesson. So I have negative 3 plus 5 times 2 plus 6, and we want to make sure that equals 37. I'm going to do the parentheses first, so negative 3 plus 5 times 8. 5 times 8 is 40, so negative 3 plus 40 equals 37, and that checks. In our last example, it's just more of the same. We're going to look at how I can simplify this expression on the left-hand side in order to isolate my variable. So I'm going to multiply everything here by negative 8 so that I can clear my parentheses. Negative 5x minus 8 minus 56x is equal to negative 8. I'm going to combine my like terms, so I have negative 61x minus 8 is equal to negative 8. Add 8 to both sides. Negative 61x is equal to 0. Divide each side by negative 61. X is equal to 0. Again, let's check that answer. So I have negative 5 times 0 minus 8 times 1 plus 7 times 0, and we want to make sure that equals negative 8. So 0 minus 8 times 1 plus 0, negative 8 times 1, and I get negative 8 equals negative 8, so that checks.